Programmable materials are also being used in aviation, and Airbus came to us and said they have this air inlet on the top of their jet engine, and as they take off, it's a hole and it causes drag. So the obvious application would be that they have this mechanical actuator, just like the flaps on the wings. And they came to us and said, we don't want to have a mechanical actuator because it causes weight, it has failure-prone mechanisms, and we'd have to have control in the cockpit. So what we really want is a magical material that can open and close to control airflow and adapt completely independently. What we've developed is a piece of programmable carbon fiber that can open and close to control airflow, either based on temperature, altitude, or pressure as they leave the ground and as they fly. And so this minimizes weight, minimizes control, and minimizes failure-prone electronic mechanical actuators. The lab oscillates between art and design, science and engineering, and we may write a scientific paper and then exhibit it in a gallery. Or we may start out with an art commission and then it becomes a new technology for an industry partner. And so we're very fluid and excited to be on all these different spectrums, that art and design and creative endeavors are just as meaningful and fruitful for the lab as pure science and pure engineering development, and we're comfortable transitioning between any of those. So the self-assembly lab is fully funded by industry collaboration, and that has just evolved based on our work being very much on the applied spectrum. And I try to have one foot on basic research, so we're inventing far future scenarios, expanding knowledge, really investigating, inventing new technologies, but also heavily focused on applied and trying to collaborate very specifically with many industries at many different scales to translate these systems and the phenomenon that we're studying, self-assembly and programmable materials, into real-world industrial applications. And it's been extremely exciting, and I think there's a symbiotic relationship there between industry and our lab. I think both mutually benefit, and we can translate these technologies into exciting real-world challenges. I think some of the most fruitful collaborations with industry that we've had are ones where we can actually collaborate to invent the future, not make incremental progress or solve some of these challenges that they have on the day-to-day or meet certain regulations requirements, but really think, what is something that no one is doing in that space? How can we radically change an industry? How can we invent completely game-changing technologies based on what we've researched and what we see in our domains to really challenge and rethink an industry or rethink a product? And then what we try to do is team up with that industry partner and transition the technology out of academia into industry, where it can meet all of their specific requirements and it can be incremented to become a real-world product.